We wind a small coil in this video. The coil will be used later on in doing a lab. Winding the coils takes a lot of patience because if something goes wrong, like a wire snag or a wire break, there's a lot of work to start the process over again. For example, I've made a holder for the bobbin to hold the bobbin squarely in the cordless drill, and if the bobbin is not centered correctly, it'll jump up and down too much and throw off the winding. Then there's the speed of the cordless drill. The student has to be very careful about what speed to run the wire at.
Oh, that snapped, yep.
It snapped?
Yep.
Why did it snap?
I have no idea.
Probably because that just did that.
When when the wire breaks, as it sometimes does, especially this very fine wire, this is about 28 gauge wire, there can be some choice language used, so I've tried to block some of that language out of the video.
Yeah, I was pulling it.
Yeah, but that's.
We had a disaster here.
The be watching this.
Bulk wire caught in the vise and it snapped immediately, rendering the coil useless, and all the old wire had to be cut off the former.
Then just never click to it. Now, tough issue too.
Yeah,
the second time round, no doubt, we'll be more careful with that. In fact, we found out what the problem was.
We wanted that to run free, but that's caught up. So probably what we should have done, we should have put it on that way, shouldn't we? And then it can't do that. So yeah, all right. So we're
using old relay coils and miscellaneous coils out of pieces of equipment is a very ideal way of getting fine wire, magnet wire, to wind our inductors with. And these inductors that we wind in class are used for radio frequency experiments, and in this case it's used for a fundamental AC principles class using resistor and inductor, and doing a phase shift measurement.
So if you hit 0,
the coils that we're trying to wind today, I'll be happy if we get anywhere between 1 millihenry and 5 millihenries. It really comes down to the number of turns of wire that we use.
It's a running game between me and my friend.
The equation for the inductor is the number of turns squared times the cross-sectional area sometimes times the permeability, and then divided by the length. In our case, we're using a air wound inductor, so permeability won't come into the equation. So the number of turns squared being on the top of the equation makes a big difference to the outcome of the size of the inductor.
He's not going to
snap it again.
Theoretically, do not want to snap it again.
I've suggested students wind it anywhere between 150 and 300 turns. I did have one student wind 300 turns on this 40mm former, and that measured at 5.5 millihenries. And then a couple of people wound a few less turns than that, maybe down around 150 turns, and that worked out to be about 1 millihenry.
Like I felt it.
Yeah, I mean, we don't want, basically this is like a director saying to his crew, no cloud shall drift in front of the sun.
I love how Hollywood actually thinks they can control the weather sometimes.
Come on.
it's interesting if you can count the number of turns on the coil, and it is very difficult when it's being wound. But if you can count the number of turns as they're going on, then you could apply the mathematics to the coil and you could actually work out
We've got a
the inductance, and that's a fun thing to do as well.
So I'm just backing it
But
up a bit.
this,
Put it back on.
there's so many
Pull it tight.
things that can go wrong when winding the coil
That should
with
hold
the electric drill.
it. No, he's still.
The number of
Always
turns
winding
is
there.
probably the last thing on your mind. Just trying to keep the wire square on the former and not breaking is hard enough. Unfortunately, on the second run, the wire decided to jump over the side of the former. That was not too bad, at least it didn't break. Hopefully we can just unwind a couple of turns of wire and we can start the process again, but we have to be very careful with 28 gauge wire because it is light and it can break quite easily.
where it went over the edge.
Which way am I turning?
No, don't go in reverse. If you go in reverse, I think you...
The final coil worked out to be okay. This particular one I think was about 3 millihenries. And all it was left to do was just clean up the workshop afterwards. This has been Greg Moore for New South Wales TAFE.
Destroyed the voice clip.
Nah, you'll be right. You're in the background. So we're nearly at the end, and I'm just watching it.
Who's video recording?
Mine. I did it yesterday in class.
This was the camera on the side.
Yeah.